Hello, my name is Shay, and I'm a recovering Ajax addict. I last used Ajax 63 days ago. My addiction started about 8 years ago at the start of my career. One of the first assignments was to update and consolidate a set of support systems our engineers were using for customer support. The only requirement was that I don't touch any of the server-side code, simply update the templates being used. As ridiculous as this request was in retrospect, I dutifully accepted the assignment and started researching some potential solutions. Being a young and impressionable software developer in the late 2000s, my attention was quickly caught by a trendy new buzzword, Ajax. It seemed to be anything anyone was talking about at the time, and all the cool kids were using it in their projects. So I began experimenting, and before you knew it, I was injecting Ajax responses all over my document body. Pretty soon, I started vocally promoting the use of Ajax. I started showing all my developer friends how awesome it made my applications feel. Online, the idea of single-page applications started gaining momentum, and I found myself evangelizing the technique. I would go from cubicle to cubicle asking developers if they've heard of our Lord and Savior, single-page apps. The effort myself and other single-page application evangelists have put into promoting this architecture seems to have paid off. Recently, we've seen an explosion of client-side frameworks aimed at helping developers build their single-page applications. You would think that this would bring me a sense of satisfaction. Instead, I've grown increasingly concerned that the splintered landscape of front-end development has blinded us to the benefits of the traditional multi-page architecture and the solutions it provides to solving common problems. Furthermore, we've adopted this approach at the expense of the accessibility and performance of our websites. By relying on JavaScript to render our pages, we've increased the number of steps needed for users to view and interact with them. With this increased complexity, we've added numerous points of failure. And since not all browsers and devices are created equally, we've made our code dependent on environments that have drastically different performance and feature support. The problem at the core of this issue is that we as developers don't fully understand the implications of this new approach, and I'd like to cover some of those and provide some potential solutions. You can think of this as an intervention for single-page applications. But before that, let's look at how we ended up into this position. When the web was created, the architecture of our websites was fairly simple. We requested a page, and the web server would return an HTML document that was accessible in most browsers. JavaScript was introduced, and developers started taking advantage of it to allow for rich interactivity in their apps. New browsers entered the market, and each providing its own set of features and APIs for interacting with the DOM. jQuery was released in order to provide a common API to smooth over the differences in these APIs. Then Ajax came along. Once our initial page was loaded, we could request more HTML using Ajax requests. And finally, single-page applications are widely adopted. Now the initial page contains almost no HTML, and instead we need JavaScript to make subsequent requests to JSON APIs, and we then use those responses to render the view. And so we've landed up in this position. If you look at how web pages are loaded in the browser, these are the 7 steps, pretty much in order. Traditionally built web pages can start rendering after step 2. Single-page applications, on the other hand, usually require all 7 steps to take place before the rendering can happen. And if any of the steps from 4 to 7 encounter a failure, the application usually fails disgracefully, resulting in a blank white page. Besides robustness, performance should also be a priority to every developer, especially if we consider that users are likely to experience a mental context switch after 1 second. Therefore, Google recommends that pages load within this time, and even use that as a factor in their page ranking algorithm. And while SPAs do generally perform well once they're loaded, this comes at a cost. And this cost is an increase in initial load times and even more importantly, the increase in the time to render, causing latency between the user requesting information and them being able to see it. Unfortunately, this metric is incredibly easy to neglect by developers since we're usually testing the app under ideal conditions. The Filament group did an experiment whereby they took the same to-do app written in the 3 major client-side frameworks to see if any of them could get first render times of under 1 second. What they found is that in most cases, the budget was completely blown or extremely tight. Something else you might notice in this graph is that although the Backbone and Angular apps are quite similar in size, there's a huge difference in the first render times. This is because it's affected not only by the request time, but also the time required to parse and execute the JavaScript. Once again, this metric is easily neglected when working on an ideal environment, since it becomes quite negligible on sufficiently powerful devices. Furthermore, it's easy to fall into the trap of thinking that the parse and execute times will grow linearly with the size of the script. However, as this research shows, the complexity of the code has a drastic effect on these times. Tim Cadillac tested the time taken to parse and execute a minimized copy of jQuery on a range of devices. And as you can see, apart from the relatively high-end devices, the time is far from negligible and can consume quite a large portion of your 1 second budget. It's also clear that these times can vary from different browsers on the same device. One of the characteristics that initially attracted me to single-page applications was that once they loaded, all subsequent navigation seemed incredibly snappy. The page didn't have to reload and you didn't see that tacky white flash. This gave me the false impression that the application actually performed better because I was using client-side templating. I figured that the reason for this was that instead of HTML, I was requesting small pieces of JSON, and the request size would always be smaller. This was my go-to argument when challenged about building single-page applications. Only after years of experience and research into web performance did I realize how self-serving this metric was. Not only did it turn out to be much less of an advantage than I thought, but I also learned that the topic of web performance is a lot more nuanced than simply measuring request sizes. Once you gzip the results, the difference becomes quite negligible at until a fairly high number of records. In this research done by Brett Slaken, he found that comparing the request size of a table of data using client-side and server-side scripting, that the difference is negligible until about 1,000 records of data. Not only was my argument flawed, but another factor that I didn't consider was that compiling the templates required CPU cycles from the browser. Since JavaScript is single-threaded, this would potentially result in the thread being locked up. This is especially noticed on infinite scrolling websites that use client-side templating. Once the next set of records is requested, the scrolling locks up, resulting in a degraded user experience. Twitter ditched their single-page architecture specifically due to the poor performance of client-side scripting. And in doing so, they managed to reduce the initial load time by 80%. But they also ensured smooth scrolling by requesting compiled HTML to load the next sets of tweets. This research shows that an over-reliance on JavaScript to render our pages has a very real impact on the performance, and as a result, negatively impacts the user experience. While it may seem negligible under ideal conditions, it's clear that the performance can depend heavily on the device being used and the connection, and the quality of the connection. The most effective way to get meaningful performance metrics is to enable real user monitoring on your application. Both New Relic and Google Analytics report detailed information which you can use to analyze not only your server response times, but also how long it takes your users' browsers to process and render your page. So you found that your single-page application is performing poorly. What can you do about it? Well, the first thing is you can limit your reliance on client-side code. Before deciding to go all in on a single-page application, think carefully about how much of your application you can build using traditional architecture. DHH wrote a great article about how Basecamp achieves sub-second response times using mostly Rails features and only sprinkles of JavaScript. They use turbolinks to ensure that there's no page, you can navigate to another page without needing a full page reload. as well as enabling Russian doll caching to cache nested fragments of HTML. In this example, Rails is caching a to-do item, a to-do list, and a block of to-dos, and a block of to-do lists. Instead of one change invalidating the entire cache for a page, they simply throw out the piece that has been changed. And they take this a step further and reuse these pieces in separate pages, further improving the response time. The beauty of this approach is that all that's required to enable it is to augment your templates with helpers which indicate which pieces of HTML to cache. Using these Rails features, they manage to get response times between 20 and 50 milliseconds once the cache is warmed. Keeping your application simple can not only improve the performance, but can simplify your code base drastically. Shopify, by moving away from single-page architecture, Shopify managed to shave 2.5 megabytes off their minified JavaScript while deleting 28,000 lines of CoffeeScript and 4,000 lines of Ruby. If you're dead set on building a single-page application because your application requires that much interactivity, or you've already built an application and drastically refactoring it is infeasible, you could investigate approaches that allow your application to run to be isomorphic, which simply means it can run on both the server and the client. In this approach, in this setup, you use Node.js. Node.js can use your application to render the initial page for the route that's been requested. Once that page is loaded, the client-side code can take over and handles all subsequent requests. Airbnb has had success with this approach. Instead, for their mobile web app, instead of throwing out the existing backbone code, they simply refactored it to make it isomorphic, and as a result, managed to reduce their first render times on 3G connections from 10 to 2 seconds. The most prudent approach I've come across so far, which tries to take advantage of the benefits of feature-rich browsers without sacrificing the accessibility on less powerful ones, is called cutting the mustard, which was first written about by the BBC web developers. On page load, they provide all browsers with the baseline experience, which is a simple HTML document which can be viewed in every browser, including those with extremely low specs. They then do a simple feature detection which separates the browsers into two, dumb browsers and smart browsers. If any of the browsers are found to be in the latter group, the single-page application is bootstrapped, providing those users with an enhanced experience that is afforded by using the latest browsers. Users in the former group are still able to view and interact with the page as a normal website. This has the added benefit of failing gracefully, ensuring that JavaScript errors don't prevent users from seeing the content they've requested. Each of these solutions has their own pros and cons and should be selected based on the specific constraints of your project. There is no silver bullet, and whichever route you choose will require some extra work. However, the benefits will always outweigh the cost because you're providing a baseline experience using the foundational elements of the web, which have served us so well. And in doing so, you can support the widest number of browsers, users, and devices possible. And I'm not saying don't build single-page applications. Just let's be considerate and make informed decisions. Sometimes I think that we're needlessly overcomplicating our systems in the blind desire to stay current. And while this is a real problem, what makes it a travesty is that we carelessly sacrificing accessibility and performance as a result, which is a disservice to our users, especially those unfortunate enough to have weak devices and slow connections. So in closing, my apologies to all of those I previously convinced to build single-page applications without understanding the implications of that myself. I hope this talk has given you something to think about and helps you make more informed decisions in the future. Once again, my name is Shay, code_dependence on Twitter. I used to work at Internet Solutions for a long time. They're a really cool bunch. Last year I worked in Berlin at Mayer Miller Smith for a year. And this year I am doing some freelance stuff under Seamless Syntax. And that's all.
No come electro por la vida.